Oh, the timer's up. I was distracted for a moment there. Hello, hello. Yes, I made a timer in Zig that runs on the terminal here. Hang on. Right. I think I'm gonna continue with the monster here because I wanna make a monster that's like a little bit more complex, I guess. So the idea is, well, okay, let's just recap a little bit there. How's it going, Blue? Where's my controller? There. All right. Yeah, we made this brown monster, and yeah, so we added this charge attack and tried to make it so that whenever the monster goes into, like, or crashes into the ground or something like that, like, it would stop its attack, basically. So that's one thing that I probably wanna fix. And in order to do that, then I think I have to think about, because I usually don't do that like with the collisions. So how the collisions work is we have an update function. This is the update function. This is like the run every frame. And down here somewhere we have yeah, physics, update physics. Yeah, so here we are checking the collisions. Now these collisions are basically, they are also like consumed when you do this. Oh yeah, that's right. We could actually, I think we could add a event listener here. Ground collision. Yeah, that's right. It's like setting on ground. But it's only if we land on something that is ground and not a wall, basically. I mean, we could do something similar to a wall, I guess. But then we also want to know the speed of collision. Does enemy knock back the player too? No. Is the answer to that. Right now, at least. That might change, but I don't know. Personally, I just hate when games do that. I mean, it kind of adds a little bit of danger to the situation, like especially like if you're near a pit of spikes or something, that you don't like fall down, you know. Like, but I don't know. It's, to me, I think I purposefully did not add it because I don't know. I just hate it when games do that. Maybe, you know, you can have a little bit, but definitely, maybe, I don't know. I don't know. We'll see. It depends on how the gameplay sort of unfolds and what you those things you can sort of tweak and stuff, I think. You just have to be careful that you're not... I think the earlier you decide on those things, maybe the better, because then you can sort of design the whole levels and everything around that. If you change something like that, like in the middle, and you have a whole bunch of levels that thinks about that stuff, maybe that will, like, yeah, you have to do a lot of work to get back. Maybe. I don't know. Hello, Polaris. How's it going? So today I'm gonna continue with the monster that I did yesterday with the monster here. What I'm thinking is I want to add a couple of like attacks and I want to fix the collision, like when it's colliding into the ground fast enough. I want it to be yeah, just to like stunned or something. Okay, so how would we want to do this? So we have this sort of collision system already, but not really for this kind of application. So I think I have to sort of work out how to actually thread something to that so I can do it. I think maybe one good way would be to have a component that will describe the collision, maybe, and then you can just get that component and look at the collision, maybe. And that could be optional as well. It doesn't have to be for every enemy. We could have a list of those collision collections. So the idea is that I would have a component that has like a list of collisions and with all the collision data in them. And when we pull this, when we get here, we look at this collision, we basically just add that collision to that list. And probably clear it at the end of the frame as well. So that gives everything in the frame possibility to look at all the collisions that are on their entity. So this collision has the two bodies that collided, direction of the collision, how far the collision went. So this could be used to calculate, okay, if the sort of the depths, I think, will be what could govern, because you have like velocity A, velocity B. Sure, you can maybe subtract them to get some sort of speed, collision speed, maybe. But I think depth also, well, I guess depth also depends on how far they, like how long the frame is and how far they were apart. Maybe the speed is better. Actually, you know what, we could actually add collision speed, calculation here. And we will return velocity A minus velocity B, and then we'll add that, and then we'll, oh yeah, that's the vector. Collision velocity, I guess. I think, because let's say A is like 3, B is 1, that becomes 2, but if it's other way around, 1 minus 3 is minus 2, so it's 2. So it's, yeah, that should be fine. Now it's always gonna be like, it's always gonna be positive, so it's kind of wrong to call it velocity. Maybe this is more like the speed. Maybe we even don't care about the direction because we kind of lose the direction here. So maybe we even go for length at this point. Okay. And then we don't really need to abs it. So we're just calculating the length, basically the distance between these, maybe even. Wait. Is it the distance? No. Of course, you're making so many types of enemies show some different behaviors than others. Yeah. I mean, it's not I think it like, because I've seen games that have, I mean, similar enemies. I mean, basically in this game, it's there's, you know, how much room for variety is there? Like, you have enemies. I basically divide them into ground-based and flying right now. So we have like flying enemies and ground enemies. Now, sure, you can have I also have enemies that jump. So technically, they're also like sort of airborne. I mean, you can have an enemy that switches from ground-based to flying as well if you want, as well. Yeah, I mean, you can have yeah, but I think enemies can be similar, but as long as they have a little bit of different, you know, they need to be, I guess, different enough for you to. It's kind of interesting how the brain works. Like, you learn the pattern of an enemy, and then the next time you meet it, you know how to you, like, instincts kick in, and you know how to deal with it, basically. But I guess maybe that's, I don't know, but maybe there's a problem if you're confused about, okay, which one was this again? Was this the one that did that, or was this the one that jumped high, or was this the one that glided along the ground or something? I don't know. Okay. Anyway, I think this is what I want to do. So let's go to components. Yeah, this just adds things here. So let's just add collisions component. Collisions. And this will simply be a list of collisions see. And we will want to have them in I forgot how to it's been so long with the SIG, I forgot how to define an array. I think it's like this. Oh, this is a slice. Yeah. That's a slice. I can't believe I forgot that. Okay, yeah. So the idea is here that you could, this is gonna get populated each frame. You're gonna be able to go in and look, okay, do we have any collisions right now? You're gonna be able to see, okay, are they blocking me? I might add some query functions here to make it easier to find. We'll see. But we also need a system for this. So let's make a collisions system as well. And what this is doing is basically just clearing out this list, which is gonna do like at the end. We don't really need anything for that. Well, we need a registry. So we actually need ECS. And so we'll go and we'll create a view of collisions, and we'll loop through those views. I think raw. All right. And then we'll just say collisions is equal to the empty slice. So just clear that out. Also, we probably need to deallocate it as well. So I'm gonna say, actually I'll add a function here, clear and free. It's a usual function to get. Well, let's just make the allocator. Yeah, and this will just be, we also need self collisions, free self collisions. Actually, if self collisions dot length is more than 0, then we do this. Actually, if it's 0, we return. Don't need to do anything, and then we do this. Because if it's 0, that means we can't free it. I mean, yeah, it has 0 length, so it's not in memory. And I just want to have this guard here. I know that allocated free has some guards against this, but I've been burned by passing read-only stuff in here, and it breaks. So I just have this guard here. We don't need to set it to the empty slice if the length is 0 anyway, so that's fine. Okay, so now down here we will say, instead of doing this, we say clear and free. And we need the get const allocator. Actually, let's get it here instead. All right. So now we need to call this update function, and basically down here we need to add this to the systems file as well. All right. Now we need to fill this array. So let's go to the collision physics update, pull collisions, Right, so this is getting called for every collision, and I believe we don't have duplicates. I'm pretty sure. Because there's two bodies, there's like two entities for each collision, and yeah. I don't think there's two collisions for each, you know, instance of collision. So I'm gonna say, because I'm gonna add, so basically, actually we can call, what do we call this? Add collisions. Add collision, maybe. Yeah. And what this is gonna do is we'll have an add collision. Basically, we're gonna say so we're gonna get both entities, entity A, entity B, which we will have here, and then T. And we'll get, so we'll do this. If try get collisions from entity A, because if it doesn't have the component, you can make a choice. You can add the component to an entity, and if it's not on the entity, we don't add it. So then we don't have to worry about it. So it doesn't exist on every entity, because yeah. But let's then get, wait. Oh yeah, so we get the collisions component out there, and now we can say collisions. So we need to append to this collisions here. So basically we will just actually, maybe it's actually better if it's a array list. Yeah, it doesn't make sense maybe for it to be, let's just make it into an array list, that's fine. Alright. We can still have this maybe. But then we can simply say clear free here instead. Alright. Okay, but now we can do append instead. And we need an allocator. Append. Collision. Alright. Hello, Rupert. How's it going? Welcome back. You were the one, you had a fake name, right? Collisions append, yes, and then we just catch unreachable. Okay, so now every frame, everything that's getting collisions, we now store that in this collision component. So you can go in here, you can grab your collisions for your entity, and we can do that, and then get all the collisions out from this list here. I wonder if you can have destructure or the destructor for components in the ECS system. I mean, we could also add like deinitialize. Yeah, and then we just call this. Oh yeah, we need to do the same thing for B as well. Ropet Patinsin from Twilight movies. Okay. I'm not that familiar. Oh yeah, so there we go. So now that should be fine. Here, this one, what's happening here? Does this have to be that, or? Yeah. Okay. Great. Now we need to go to the init, dinit, and we basically, we can just call this anywhere, basically. Okay. Now, that's all set up. We also need to go to components and add this this export, output, import, output, import, export. Let's see, collisions. Yes, collisions, not components, collisions. There we go. Most people weren't even born then yet. Is that true? I was immediately starting to think, when did the movie came out, and how many people exist, and how old are they, and how I was trying to solve the problem. How much, you know, on the pie chart, how many are born after the first movie? I don't even know when it came out. Wasn't in 2000 something, or two, I don't know, 2010. Was it in the 2000 or 2010? 2010s. Alright, let's go back to the monster. Where is the check for the collision stuff? So whenever we go into stun, should get stunned. Yes, okay. Okay, yes. Now, this is what we want to do. So I think, yeah, now we can go into this and we can add a convenience function for checking if we have collided with a blocking entity. And if we have, then I'm gonna say we get the collision out. Now, there might be multiple. It's not that common, I guess, but there might be multiples of this. So we probably... Actually, let's just get the whole thing, maybe. Well, the whole point of this is to get all those things. Let's get a list then. And I guess this list would be empty if it's... Well, could still be fine. 2009. Zig version 1.0 when? I don't know. Jai release when? I don't know. Is Jai even... is that released now? Or I saw some videos recently, so I was like, wait, are they preparing to release it or what's happening? Zig is like working on 0.16 right now, and it is still looks like some ways away. Yeah, Jai is not released. Yeah. Even if Jai gets released, I'm not sure if I'm... I mean, to me, it's kind of like... I mean, Odin and Jai seems very similar to me. There might be some features that I'm not thinking about, but... I haven't looked into all the features and everything and all the different things, but they seem very closely related to me. Collision. No, yeah, that's in C. Collisions. No, wait. That's right. Do I want to compile a list of collisions or... Actually, it could be an iterator. Collision iterator. Whoops. Okay, let's do this first here. So we have function next. It gives us a collision. Collision is that. Iterators, yay! Yeah, I also love iterators. I mean, I implemented a whole library for generic iterators. Actually, maybe I should use that to make a point here. But we'll start with defining this one first. Actually, you know what? I should actually use the iterator library because that has the power to filter, and we might... That's the only thing that we might need here. So basically, yeah, basically what I want to do is I want to define a function that filters the things. We should have like iterator. Yeah. Filter iterator. yeah, there's even a filter function on the thing as well. I have to sort of remember how this works now, but it should be kind of... Yeah, you have this from function. This is where you start from, and then you can pass in like any type of source. And if it's a list, then yeah. Forget this guy. So this would be... Where do I have this iterator? There we go. And this would be a collision. Power of a library, yes. It's kind of... The power is that, yes, it can be very powerful, but you have to also know how to use it, and that's the crux. But yeah, okay. So I made this library, and has collided. Yes. So let's get the collisions first. All right. Now I'm gonna do iterator from collisions items. So I mean, I can basically just return this. So this will take this. This will take any source. Now, if it's a, I guess we need an allocator as well. If it's a slice, it will make a slice iterator from that. So now we have a iterator from this slice. This is the source of the iterator. And then we can also say dot filter, and we need a function. So you could define a function straight in here, but I would that's so clunky in SIG. So I would rather just make a function out here and say is collision blocking, and so I just need to refresh my memory on how this function should be, because I don't remember, and I didn't add documentation for that either. This only takes the one type. Do we have filter with context? Because I think we need one. No? We only have map with context. So basically context you can pass in something else that you can then access through the filter. Because I need that in order to get to make this work here. So let's add a filter with context, just the same way here. And then this would be, hang on, what's going on here? Oh yeah, so that should be the same thing. This should be context iterator, which we don't have yet. All right. All right, let's just copy this. Call this filter. And this is filter. We are getting... we're just copying the type of the iterator, and we don't validate. Hang on. Oh, it has its own thing. Okay, let's not validate. Let's do we'll do basically the same thing as we're doing up here, except we don't have a U. We have a context, and then we return. Now we need a filter context iterator. All right. Yeah. There we go. Let's put this over here. Now we'll copy U. You are now filter context iterator. And we need the context type. And now you take context and T. Wait a minute, is this Vim or not Vim? This is Neo Vim. So it's kind of Vim and kind of also not Vim. Yes, contexts are amazing. Explicit contexts are also very good. Let's see. So next should adhere. So this has to adhere to the iterator interface. But yeah, we need to store the context. Yes. So we're storing the context there. And is this a pointer or is it? I see, yeah. So this is a pointer. But they should rename every context to consent. I'm not sure. I don't see the. Yeah, I don't understand. Anyway, I don't even know where to begin. I consent. Consent to being sent. Explicitly sent into each function call. Okay. yeah. I was just trying to find something there. I don't know. Okay, context. We have the context, so now we need to pass the context in there. Actually, now this is also a pointer. Let's actually check the map one to see. Yeah, it's a pointer. Actually, okay, so this is not a pointer, so we pass in. Okay, well that's fine, I guess. So this is not a pointer. We'll keep it the same. Okay. All right. Okay. Yeah, I think that's it. What we need to do. Now let's go back here. We should now have a filter context iterator. That should all be good and well and done and fine there. We should really have like validators here so that we can actually see what we should send in, because I'm not gonna add it right now. Okay, so now this should be a filter function. Now we get the context. The context is gonna be, actually this could just be the state machine context. Yeah, because from there we can get everything. And then we get a collision, which is this. And we return a bool. So that is our filter function. Now we can pass this in here. So we need to actually implement it. And so what we'll be doing here is collision blocking. Yeah. So what we'll do here, first we need to figure out which is the other entity. So other entity is gonna be if collision. Actually, I think I have like utils entity equals. No, where do I have this entity equals? ECS. Okay, so this is gonna be entity collision entity or body a key. Okay, so if they are equal, then that means that the other entity is gonna be body B key. Else, I know the formatting here is kind of weird, but oh, it kept the format. No, there's a issue here. Okay, we'll see what it formats it. Probably not something good. Okay, so now we have the other entity. So now we can see, now we can get the physics system. From there. And we need S. And we can say if collision groups is collision enabled for actually we don't need to know which the other entity is. We can just pass in entity A, entity B. Well, let's just do that. Let's just get entity A. Yes, I did. I mean, it's not that, it's not like super fancy or anything, but it works for the thing that I'm doing here. The most advanced thing is the collision system. Because that just takes so much computer resources. So you have to apply some tips and tricks to make it work without lagging. I did try to make, you know, this elaborate physics system where you had like collisions that could rotate the bodies, like, you know, you knock a box on the edge and it will fall over, like it will rotate and fall over. But I never got around to that. That's kind of where the extent of the physics system is right now. Okay, so if the collision is enabled for those two, then we return true. So basically, yeah, basically we just return this. Okay. And we don't even need this. All right. So now we should get all of the we should get an iterator that is passing along all collisions that are blocking. So I guess this could be called now get blocking collisions or something. Yeah, I really like this iterator system. It works really well. Also, yes, this needs to be context now, and the context we need to pass in is this here. Yeah, it needs to be a pointer, because if it wasn't a pointer, then this iterator will have a variable size. And that's, yeah, we can't have that. And but then it also means that we need to keep this, we can't really do this. I just realized, because this pointer is not gonna work. It's basically pointing to this local I believe this would be just a pointer to what's it called? The stack. Excuse me. Not just mechanics, but also electricity and thermodynamics and stuff. No. Just the basically just positions, velocity, acceleration, gravity, not between objects, just a global gravity, and then collisions that if two bodies are blocking each other, then the collision is also resolved in, like, they will block so you don't fall through the ground. Hello, Tuni, how's it going? Looks funny. What looks funny? All pointers have the same size. Yes. Why not just use pointers everywhere? Isn't it C++, by the way? This is SIG. Because, well, okay. It's kind of, okay. Pointers, well, they point to a address in memory. Okay, that's all they're doing. All pointers in a 64-bit system is 64 bits or 8 bytes long. So because that's all you need to point to a specific address in memory. So all pointers are the same size. I mean, there's some variation, especially on like older systems. You had like near pointers and far pointers, but here is only like 64-bit pointers. But you know, for example, here I can't just pass this pointer here, and the reason is that sure, within this scope, this pointer is valid, right? It has a valid because, well, it's valid within this scope. Let's just leave it at that, okay? But the problem here is that we're returning this iterator, and this iterator will use this pointer later when we're actually iterating over the values. So if you pass this pointer here, which is only valid in this scope, like at the end of this function, it won't be valid anymore. So you're basically passing an invalid pointer here. So later when the consumer will use this iterator, this pointer will no longer be valid. And the reason why it's invalid is because it points to this function parameter, and all function parameters are basically, they're placed on the stack when the function is called, and then after the function has returned, they are discarded basically, and then that memory can be used for other things. So this pointer might not actually point to this data that was meant to be here. So that's why you can't just use pointers everywhere. If you want to use a pointer, you have to have a stable section in memory where that pointer never changes the underlying data just because you're calling another function or something. Why don't you provide pointer to the get blocking collections then. Yeah, I mean, yeah, that could be a solution. I haven't gotten into thinking about the solutions yet, but yeah, that could be a solution. I usually pass the constant here because it's easily sent. Yeah, it's easily. Actually, you know what? Let's see. Well, that's one solution. Where is where I want to use it? So it's over here. Now, if we want to do that, we have to make sure that from where calling from has a stable. Also, it has be able to have a stable pointer. So basically, like here, we could say we could create the iterator with the pointer to this context, and as long as we're in this function, we can use the iterator. So that's fine. In C++ to see the receive pointer everywhere, it seems like maybe that's bad. I don't know. Well, I mean that we have the same problem. We're sharing the same. There's the same problem is basically exists in all programming languages. It's just that not all programming languages have pointers, but basically every programming language that has pointers and can turn these things into pointers has that same problem. So you just have to be careful of how you use pointers, basically. You have to be aware of how to use them. What is a stable pointer? So what I mean when I say a stable pointer is basically, let's say you have a program, and to have a stable pointer, what you're doing is you're saying that, okay, well, this region of memory is gonna be how you say it? Well, we say allocated. So you allocate a piece of memory. Now this memory is going to be stable, basically, until you free it yourself. So you're allocating a bunch of memory. That basically means that the operating system, or yeah, I mean, it comes down to that the operating system grants you a piece of memory that you can now use freely, and then you decide to, well, I'm gonna populate this with some data, and the operating system promises not to touch this region of memory. So you can use that region of memory however you want, until you say, well, now I don't need it anymore, so I'm gonna free it up. And that tells the operating system that, okay, well, now other processes might use this data, or you might use it again later if you allocate more memory later. So it's basically like borrowing a box, maybe you could say, or borrowing a house, that has an address. And as long as you're like granted from the government or something that you can use this house, then you can put whatever you want in there, and it's always no one's gonna touch it, except you. And then you say, when you don't need it anymore, you say, well, now I don't need it anymore, so now you can go ahead and use it. And then the government can do whatever it wants to that house. And then, but then if you try to use that same address after that, you don't know what's gonna be in there, because it might have changed now. So that's an unstable pointer now. If you're pointing to that house, now that's an unstable pointer. Okay. Yeah, okay. Well, I didn't know that you know that, but yeah. It's also fun to try and explain these things. I'm basically, in my mind, I imagine I'm explaining to someone who have maybe no idea about computers at all, just to cover all the bases. You know, you never know how much the person you're talking to has, you know, that understands. So so if you miss like a detail, it feels like, okay, there could be like a lot of misunderstandings. Yeah, okay, great. So you understand. Good. Not changing during lives, yeah. Rust explainer. I don't know what that is. That a complement, I don't know. Yeah, so basically, I mean, okay, another way to put it, like a stable pointer is like when you have, I guess, control over it. Any local variable like this is gonna be put on the stack, which is it's kind of like a temporary space for local variables, parameters into a function that's getting called, and those when the lifetime of the function has ended, which is after it has returned its value here, after the function call, then the location of this variable is no longer it's no longer stable. It's only stable within this scope here. Yeah. But yeah, one solution, as you pointed out there, Ropet. I'm gonna say Ropet because that means the scream in Swedish, so I think it's kind of funny. Or the call, or well, the scream is funnier. Skrik is scream, but rop is, I mean, I guess it's like shout. The shout. Okay, I'm gonna call you the shout, or ropet. When it goes out of scope, it frees itself. I mean, I think it's easier if you see the assembler code, or the assembly code that is produced by this. But basically, assembly is like the code that actually gets run when you run a program. Every program is compiled into assembly code and then run. And so what's happening here is that when in assembly, when you call a function, it's kind of different. You have to sort of make use of, you can't just like, I want to call this function. Basically, a function call is kind of like how do you say it? Like each parameter into the function is getting put on something called a stack, which is in a region in memory that is used basically for local variables. And every time you call a function, you put things on the stack. And the stack is kind of, it has it basically is a, how you call it? It basically is a pile or a stack. That's why it's called a stack, because you're stacking things on top of it. So every time you put a thing on the stack, so here's the stack. Let's say you put a thing on the stack. That's now the stack. It's got one item in it. It's a 0. You put something else on the stack. Now you have 2 items. Something else. It can be anything here. So basically now we have a bunch of numbers on the stack. Now how the system works. Now you can pop things off the stack as well. If you wanna, like, you can get, basically the computer also has a stack pointer, which at first is to the set to the first item. So that this is the stack at first, and then the next instruction might add something to the stack like this. So we have a 0 in the stack. Now the stack pointer is at 1. Okay. Now we add something else. The stack pointer is now at 2. Okay. But then you can also pop things off the stack. Then you decrease the stack pointer and you take the top item off, and it gets sort of put in a registry, I believe, if I don't remember correctly. But you can also get the value of the, like, let's say you have this and you want to know, you have this this thing here, and you want to know where is this data stored. So then you have you know where the stack pointer is. So let's say it's here, and you put this 2 here. So let's say this 2 represents context. So then you can look at this. You can look at the address of the stack pointer basically to get this value out. But so that's where this is stored. So that means that when this function returns, it's gonna pop all of the local state off the stack. So at this point, the stack is like, let's say it's like this. Now later on, you might call, if you have a pointer to this context, the pointer to the context actually the stack pointer at this moment, which is 2. Okay, so later if you want to use this pointer, it just points to this part of the stack, and this could be populated by something else at that point, because you could have called some other function, you call some more functions, and it puts the other things on the stack now. Now the stack is always in the same region of memory, so that doesn't change. So if you point to stack pointer 2, that just means that's just a temporary place basically for local variables. It's kind of hard to explain. I'm not sure if I did a good job here, but yeah. I guess it's easier if you have like a diagram and whatever. But basically, that's why we cannot use this pointer here. But as you said there, Rupet, we can put a pointer here, but then you have to make sure that the caller makes sure that you can use the pointer correctly. But another thing is that I already have a pointer, I realized, in here. So I have a pointer called reg, which is the actual thing that we need down here. So we actually just need the registry, and that's already a pointer. Except, yeah. So that is a pointer. I think I want to change this actually. Do I actually use map context anywhere? Yes. I mean, it might be fine to dereference registry. I'm not sure. But then this is kind of weird. This is like copied. That's usually not how I do it, but that might work in this case. Okay. Yeah, I think it's fine. It's probably fine. Okay. So we don't have to worry about it. That should work. All right. You could do is also you could like make this instead of this actually. I mean, I think it makes sense if the function also takes a pointer. Actually, I think we probably want to change. We probably want to change that. Yeah, it doesn't really make sense. Why should we dereference it? Really, let's just not do that. And let's make this a pointer. Because if you're passing a pointer anyway, it has to be stable. It's fine if it's a pointer. It's actually better because you get more, you can do more things. Except it should be, there should be no side effects in here. That's also very important. But or at least that's, you know, it helps keep the bugs away. Okay, let's do the same with map actually, because yeah, it makes no sense to have this like this. I don't know why I did like that. But maybe I didn't see what the problems could be. Alright. Now, I have to change these things. No, down here. And you take a pointer now. And you also take a pointer. Alright. Yeah. Now back here. So now you can take a point. There we go. Alright. So now we should have a way to get all the blocking collisions. So we can go to back to the monster and it should get stunned. So let's now take, well, we could make a convenience function as well for this specific thing, which is like so what I was thinking, like get largest or get highest blocking collision speed. That's very specific here, but that should be good. We need the context, and we're gonna get a, I guess, a nullable. No, let's just say 0 means no. F32. So we're getting an iterator. It has to be mutable. Get blocking collisions. Okay. So we have those. Now we can iterate through those, and we get a collision. So this is the blocking collision, hopefully. And we have to keep track of maximum max index, which is, I guess, 0 right now. And we also need index, current index. So if, actually we do need, no, so we need like max collision. And let's just say no, because yeah, we can't, it's not an array, so we can't access it like that. So we need a max collision, and then we need, no, that's what we need, yeah. And so here we're gonna check, so if max collision, and if collision speed is greater than this collision speed, now we want to set max collision to this collision. Alright, now that it could be a pointer, but I mean there are a bunch of things that we have to copy, I guess. Yeah, sure, let's just make it a pointer. Then this is gonna be, whoops, yeah, that's gonna be collision. Now we actually need this to be a pointer now. Whatever, let's just not make it a pointer. So now we update the collision, the max collision to be this collision, Yeah, and that's what we do there, and then we return the max collision and collision speed. Except if we have max collision, then we do this. Else we return 0. All right. So that should return the highest blocking collision speed. We get the blocking collisions iterator. We keep track of the one that is highest. I guess we can call this max to make it more consistent here. Get max blocking collision speed. We're iterating through them. We're checking, do we have a max collision? Actually, if we don't have a max collision, then we should just set it. Okay. And we're checking if the speed is more than the collision speed. Wait, this should be the other way around. If the new collision is more than the stored one, then we set this there. See, it's good to go through it one more time to see what you actually did. Yeah, we started with the first one there. Okay, and if we have one, then we return the collision speed. Otherwise, we return 0. Great. So now we can go back to the monster, and we can say here, instead of taking the length of the velocity, we will take... I guess that could work as well. But anyway, we will take... get max blocking speed, and then we don't even need to look at this anymore. So if this is less than the speed threshold, we return false, otherwise return true. Okay, let's see if this actually works now. How do we check collision? Like, how do we check every frame two objects coordinate are overlapping? I can go through the collision system if you want. It's depending on how deep we want to go, it can take more or less time. But I have no problem of doing that. I'm just gonna see what's. I'm just gonna test this here first. Let's see, Victor. Okay. Oh, this is a vector. No, what? How is this a vector? This is not a vector. This is F30. There we go. Okay. I just put the wrong type there. See if we can test this now. So let's charge into the ground here, maybe. Whoop. I think it crashed. Yeah. Oh. Okay, I see. Yes, I see. I forgot to add collisions. So it's crashing because I forgot to add that to the game, to the monster. So we need to go in here and we need to add collisions to enable basically this feature. For this monster. An overview of the idea. Yeah, I'm gonna go through that. Let's see here. Boom. Okay, yeah, it does work. Let's see if... Yeah. And... Okay, well now we could also, like, yeah, I would like to fix it a little bit more, because we are sort of back to where we were before, except that now it's more robust. But what I also want to add is, like, if the sort of normal of the collision is like near the, no, well, oh, sorry, 1 second, I'm getting a call. All right, sorry, I'm back. Okay. I wonder what the normal actually is. But I'm gonna guess the normal is gonna be... Maybe the normal is the... Oh wait, no, the normal is the face of... It's like perpendicular to the face of where you're colliding, I think. But then there should be like two normals, maybe. Or... Yeah, I don't know. I'm gonna log it, I think. I'm gonna log the normal. Get the max collision. I'm gonna log max collision normal. Okay. And if it's how I think it is, then it's always gonna be like 0, 1, 0, like something like that. Okay, so this should be like 1 or something. 0, 1. Yeah. So it basically saying that you can use this to detect the slope, I guess, of the ground that you're colliding on. So if you would collide on a wall, it would instead be something like -1, 0 if it was like from the right to the left. But this is 0, 1, which is like 0 in the x-axis, 1 is like the y-axis. So I think... So how would we think about this in terms of velocity? Because, okay, the idea that I have is like maybe we could actually calculate. So we have the collision speed. However, it also depends on the angle of collision into the ground. So we could take the angle of velocity and somehow scale it with this normal here. I'm just trying to think of how that would be. I need to be 1 second here. Are you back, Blue? Let's see. Let's do this. Let's get max blocking. Okay, this might not be correctly calculated, actually. It's not just velocity A, velocity B. Because you gotta take the normal into account, I think. Either we could just use the depth, but I don't think the depth also feels very variable depending on how close they were and stuff. Like technically, if two bodies are very close, they have the same speed going towards each other. Next frame, some time passes. They are now colliding. The depth is going to be large because they were so close the frame before. But the actual collision resolution should be exactly the same as if they were farther apart and then some time passes. They have the same speed as before and then they collide, but now the depth is like very small because they were further apart when the frame just happened to be in the time frame there. So those two collisions has to be, has to have the same resolution. So depth, I don't really know what we're using depth for, to be honest. Like, but yeah, because those two scenarios should be the same in a continuous world. Which we should like effectively be in. So, but how would we use the normal here? I think we wanna say maybe we'll take the dot product of I don't remember if there's an inherent what do I say? Like if like the body, no, it couldn't know which, but it seems like the ground is always the second one. So if we just assume that we just assume that the ground is always like the second one. Or maybe the normal becomes like that because of the static objects being like infinite mass. Something like that. Well, okay, either way. Yeah, this doesn't even make sense either, because velocity A... what, or does it make sense? I don't know. I don't know if it makes any sense. But let's assume that velocity A is always... Okay, let's do velocity... So velocity... Yeah, because velocity B is always 0, actually. In that case. Okay, well, let's take the dot product of... I think it's... Is it what you call it, like associative, or like if you flip the arguments, is it gonna be the same? So you have this vector and that vector, that will be like small negative. This vector onto that vector doesn't make... Oh, that's basically 0 because it's straight up. Well, let's keep them. Let's do this, I guess. This should be 0, I think, because velocity B is always 0. Then this should be like... Well, isn't this just the depth now? Maybe. Well, it's sort of the depth with in relation to the normal, maybe. No, wait. No, that should be... That, I think that's fine. I think. Should I sum them? I don't know. Feels so experimental here. Well, let's just take this plus this, I guess. Maybe. And do we then also take the abs of this? Or is it negative? I don't know. It doesn't really matter right now because we're just... Okay, let's just try this. I could look up some formula as well, but I don't know. Usually when I've made things myself like that, trying to look up a formula uses some variables that I don't have, or an entirely different thing. Okay, there we go. Wow, it works. Yeah, it does. I mean, yeah, it works. Boom. Yeah. And then it's like sliding along the ground. It works exactly how I like imagine it. Okay, cool. Awesome. Great. So that works really well. Cool. Okay. Yeah. I was actually not expecting that, to be honest, to just work like that. Okay. Right. I mean, there might be some bugs later on. We'll see. It works in this case, but it might be... There might be some ticking bombs there. I don't know. Whatever. That we'll figure it out. Okay, so another thing that I want this to be is I want this to have this monster is gonna have like some more attacks, types of attacks. I also want to kind of tighten up this charge attack because it feels, I don't know, there's something, it feels a little bit I don't know, it feels a bit slow maybe. But maybe it is good. Because when you have like multiple enemies, like sure, if you have one of these, it's pretty easy. But if you have like multiple at the same time, it's actually really helpful when they, like, if you have telegraphed attacks. Like that. Okay, well, so let's leave that for now. I'm gonna add another, like a melee attack now as well. So basically, it's gonna be entering another mode that you can also telegraph, where it's gonna hunt you and then finally, I think it's probably gonna hunt you for some time. It's gonna be a maximum time, and it's gonna hunt you and try to attack you with a melee attack. So let's add that. So here's our aggro mode. We have if should charge attack. Let's also add should melee attack, or should like hunt. What was this should melee attack maybe? Yeah, let's just do this first. Now we're setting that state. Now let's add this state here, melee attack. Alright, so how's this gonna work? Because this is also kind of like not really the usual thing that I have. But there is some functions that we can do with this. I think first thing we want to do is we want to set the velocity to 0. I also want to note this with a different color. So charge attack is dark red. Let's make this like, I don't know, dark purple, sure. Alright, then I have an update function. So it's gonna be some sort of telegraph. So let's also set duration to melee attack duration. And let's do 2 seconds. And let's say that the first second it's gonna telegraph. So it won't spawn the attack until 1 second in. I forgot how to actually do this. We have create attack. Let's do damage. Follow source. That's if you have an attack that should follow the monster that. So a melee attack would be a good candidate for this, because you want the. It's not like the if you have a sword. If the monster has a sword and you hit the monster so that the monster gets knocked back, the sword is still the sword won't stay in place. It will follow the monster in the knockback thing. Okay, well then we have a hitbox. And we have hurt delay. Now hurt delay should be melee attack. I'll just say hurt delay here. So the hurt delay is 1. Damage and hitbox. So the hitbox is okay, what would the hitbox be? The monster is 12 by 26. It will probably be something like, I don't know, 12 by 8 or something like that. Or 6 maybe. Okay. Actually, this should be here. We're just creating the attack. And then here we should have the common behavior. We should have if the state has ended, then we set the state back to aggro. All right. And right, and I also want to have a cooldown for the melee attack. Can melee attack at, and that should also be set here to be melee attack cooldown. When you go back to aggro, when you enter aggro mode, there's a cooldown for the melee attack. So basically, anytime the monster is like, you know, exiting some sort of action, some sort of aggro action, like attack, it go back to aggro, and then it doesn't do any attacks at all until the cooldowns are up. But then we have to decide, okay, how do we decide if it's gonna make a charge attack or a cooldown, or I mean a charge attack or a melee attack? So let's make a melee attack cooldown, and that should be like, I don't know, 1.5 or something, I don't know. All right. Right, so now we need to implement this function. Let's copy this. So, yes, we need to look if the timer has expired. We also need a distance. So this would be the melee attack trigger distance. Which I'm gonna say like 50. So if you're super close, it's gonna do a melee attack. If you're farther away, it's gonna do a charge attack. Well, we should then make this priority here, because otherwise it's only gonna do charge attacks. So now it's basically like, should melee attack is checked first, so it has priority over charge attack. But you can also do like let's say we add a chance here. So we're saying, okay, it should be a chance to make a charge attack even if you're close. We could also have like a sequence thing, like first you do a charge attack, then a melee attack, and then you switch between charge and melee. Yeah, there's a lot of options here. Alright, let's be close. Okay, now it's doing like a melee attack. Oh, I see. So when we create the attack, when we do the hitbox, we have to add the offset of the monster. And also we need to, we also need to add some sort of offset that is like towards the player as well. I'm gonna do this. I'm gonna go enable I'm gonna enable combat hitboxes so we can see, so I can show here, because this should draw the attack hitbox of the monster now. Or not. Well, maybe it does, but it's... Okay. What are we missing here? Duration. Oh, I see. This is wrong. This should be this. Well, actually, that should... well, let's set this to that to be sure that it's correct. No, not the cooldown. It should be duration. Well, it should still work, but duration. There we go. All right. Actually, I'm not sure if you have to add the hitbox or the position. Yeah. Let's remove this. That might already happen, actually. I just forgot how it worked. Okay, now you can see it's like attacking the attack hitbox is spawned, but it's like in the middle of the thing. So so we need this hitbox to be offset by a little bit. So let's make attack offset. So this would be like how far out would we want it to be? We can also adjust like the Y position to make it be further down or further up, but maybe middle makes sense for this monster. So I'm gonna do like only X, and we're gonna say hitbox, which is the monster, and we can get the width of that, so it will move out by the width. We could also take, or we could take the melee. No, so there, now that should be like centered on the edge of the monster. So if we add the width of this guy, that should now be, well, it has to be like over 2, I think. Okay, but now it only works for the right. So what we want to do is we want to take the direction of the, actually do we? Yeah, we have apply direction. So the direction is either left or right, basically, and so now this will kind of adjust. So if you have like a vector that's to the right, but the monster is facing to the left, it will switch it over to the left. We could take offset X. Okay. Now let's see if this works. It's nice to have a bunch of convenience functions, but you also have to remember everything. There we go. And it's attacking like in the correct direction. Okay, now one thing that I would like to have is like, even if you're close, maybe, because you can kind of cheese it, maybe. Maybe sometimes it like backs off and starts to do the charge attack, like that attack, but it's like, if you're close enough, like there's a chance that it would, instead of always doing the melee attack, it's gonna back off and do the charge attack. So let's see. So instead of having this basic like priority list, let's think about something else. How would we make this work? I mean, I guess we would check like, okay, if we should melee attack, well, we might want to do a charge attack instead. Even if we should melee, even if this is true. So it would kind of look weird if we have like, if should melee attack and then we don't melee attack. But yeah, basically, if the conditions for this is true, I guess we could check like if both of them are true. Like if both of them are true, now we can make something more interesting there. So then we can just say random. So we can just say like a random chance, 50-50. If true, then we do melee attack. Otherwise, we do a charge. Like, I'm gonna do kind of like an evade and then charge. So it's like an evade, then charge. Whoops. Charge. Yes. So let's put this over here. We need a pre-function because I'm gonna determine now a fly direction. Let's also mark this with some color. So charge attack is like dark red. Let's make this, I don't know, a little bit less dark or a little bit more grayish red. I don't know. Anyway, so monster fly direction is gonna be get direction to player. I guess we could add a convenience function that is like get direction away from player, because that could be used. I can see that being used in other places as well. So let basically, yeah, you take the angle 2 and rotate by pi. I mean, we can just do this. Okay. Get direction away from player. Okay. Now, we also want to set like a duration, I think. So let's set duration to be evade duration. We need an update function. Still want the common behavior. Oops. We want to say, so if the state has ended, the duration is up, then we set the state to charge attack. Okay. Otherwise, we are going to do a flying motion. That is gonna be evading the player. And the speed is evade fly speed. Monster fly direction. So we need to get the monster here as well. Alright, so what is the evade fly speed? Let's make this here evade. Duration is gonna be, I don't know, 2 seconds or 1.5. I don't know really what's a good one. This should be fairly fast, I think. It's just the evade should be fairly fast. So charge is 300, but it builds up to 300, so it can't really be like 300. Let's do like 150 and see how that looks. Okay, so basically, yeah, we have this evade and charge. This is gonna be set if we can both melee attack and charge attack. We're gonna pick a random. If there's 50, we're gonna choose melee attack. Or I mean, yeah, 50-50. If it's heads or tails. Heads is melee attack, tails it's a charge attack. But we do a evade first. And in the evade, we will pick a direction that's away from the player. We will do this for this amount of seconds. And then when the after those seconds, we will do a charge attack. And during the evasion, we will fly away from the player. Okay, so let's see if this works now. So we have to get close. Okay, it's doing melee attacks. Only melee attacks, come on. I'm either very unlucky or this doesn't work. Okay, well this is very, very, very unlikely. I'm gonna try a couple more times because I'm not trusting my luck here. One more time. Okay. It doesn't seem to work. So why is that? What is happening here? I'm pretty sure this is gonna be like 50-50, right? Is it because these two are never true at the same time? Oh, you know what? It might be that because the charge attack has a longer cooldown. Ah, yeah. Yeah, they should have the same cooldown. Let's just make them have the same cooldown. There we go. Now it's doing that. Okay, cool. I think it should attack faster, maybe. Or maybe this should be longer, I think. I don't know. It just doesn't seem that threatening. Because you can see it standing still. Okay, then you just move away and that's it. You can even land a hit. Yeah, it's way too slow. Well, it could be a little bit faster. So hurt delay, I guess 0.7. And this could also be then a bit lower. Just tightening it up a bit. You could also have like this type of enemy which is very slow, so it's more easy, and then you can have more you know, harder enemies later in the game. Oh, you can actually like stun it while it's doing that. I feel like when it's charging, yeah, we don't have a duration for the charge. It's basically hard coded down here. The ratio is less than 3. Let's do 2. Or I guess hard coded. All of those constants are hard coded, but I mean magic number stuff here. Okay, yeah, a little bit more threatening there. Also that one, but now it's like slower to start instead. So I will take this maybe times 3. So either I want to increase the health or make like the first time it goes into aggro, the duration. I think that cooldowns should be way lower the first time it goes into aggro. Like on transition from flying, which is the like non-aggro, to aggro, I think we should set these to be way lower. Just I don't know exactly how. Well, I know one way is to add a flag, but yeah, I guess we just add a flag. Has attacked. So then it's here as like if has attacked we still want a little bit of cooldown, but I'm gonna say like initial attack cooldown here. Which is gonna be 0.5. So now it's like the first time you aggro it, it's gonna be swirling around a little bit, and then attack you almost immediately. Or not. Okay, definitely increase this, maybe even double it. No, it's still, that doesn't work. Oh no, if it has not attacked. That's right, if it has not attacked. But then at the end here, let's rename this to has aggroed. I don't know if this is a correct spelling, but whatever. Like, is there a W in there? I don't know. I think it's stunned too long. Yeah, this definitely stunned too long. I think also, like, if there should maybe be another mode where it's like it doesn't get stunned, but it like gets whoops, what happened there? There's some crash here. Okay, let's change the cooldown and yeah, so there could be one where it's stunned and one where it just cancels the charge. But it won't cancel if the speed is like very tiny. So let's just do, I don't know, 10. It should be larger than stunned. Should cancel charge. Then we set back to, oops, aggro. Actually, we could have it here like a whore. Okay. Now, what was it? I was thinking about. Yeah, I would like to have maybe some sort of bias, like each time it does the charge attack, the chance to do a melee attack increases and vice versa, or something like that. So there's like a weighted thing. But whatever. What was I thinking about? Oh yeah. So I also want to increase this a little bit more. Like the hitbox for the sword needs to be way larger, I think. Because it's really doesn't punish you to just get up and try to hit it once it's like telegraphing that it should attack. You should back off at that point. Yeah, there you see, there it canceled the attack when it reached the ground there, instead of getting stunned. Okay. Yeah, and there when it glides around along the ground, it also it doesn't cancel because the collision speed is like too small. I think also, like, similar to how we have a evade, like if you go up close to it, it's like sometimes it does a melee attack, sometimes it does an evade and then charge. I think I want to have a similar thing but for long range as well, where it like tries to hunt you, and then do a melee attack. Let me see if I can. No, I still don't get hit. Okay, there I got hit. So maybe that's fine. Okay, but yeah, that's the last thing I think I want to do, is I want to have down here, so here, so if we can do both, we do this, but if we can do a charge attack, basically we could change the charge attack into being either hunting to hit the player, or do the actual charge attack maybe. Or we add a new type of thing. Actually, we'll do this. Should hunt attack. So hunt attack is like it's gonna go close to you and do a melee attack immediately. It should basically have the same trigger distance as the charge attack. The timer, I think these timers should be they should be like it should just be one can attack at. Because, yeah, that makes sense. Alright. And then it's like, I guess, ranged attack, trigger distance. Makes sense. Whatever. Let's just do that. Right. So if we can do both these. Now this doesn't really make sense anymore, because it's basically, if we can't melee attack, we also can charge attack. So this doesn't make sense. This should just be removed. I think basically we should just say, if we can melee attack, then we throw a coin and say, okay, well, either we do the melee attack or we do an evade and charge. And here we say, should charge attack, should hunt attack. It should be like should range attack or something. But here's the same thing. So we do a coin toss, and if it's true, so here we do charge attack. Well, let's do charge attack there, and then here we do like hunt attack. Right. So we're doing another. Let's just copy charge attack, and we'll call this the hunt attack. And let's make this a little dark. Wait, let's make this cyan or turquoise, or I don't know what to call it. And then we get the direction to the player, so we should go towards the player. Except I think that's gonna change every. It's gonna be in here. And we're not gonna get stunned. And we're not canceling the charge. And we don't really have a... Well, we could have a duration, I guess. Yeah, let's add a duration to that one. So this would be the hunt attack duration. Let's set like, I don't know, 2 seconds. So after 2 seconds, it basically gives up, is the idea. And it goes back to aggro. So if state has ended, we go back to aggro. Yeah. Hunt attack also, we don't really need to... Do we want to set the 0? Let's remove that for now. That might look too weird. So basically changing the direction to the player every frame here. We don't need to do this. I mean, we could have... We could actually do this, actually. Hunt attack speed. And so basically, or max, basically here is like it starts at half the attack fly speed and then it builds up to higher speed over time, and that's the fly speed. And then we have the direction there as well. We don't need to get you multiple times. Now we need to define that. Fly speed. Let's do like 150. Alright, so now it should follow the player, and we should also have now... I mean, we could just say should melee attack. And then we set the state to melee attack. So we're hunting. Basically, we're just moving towards the player to initiate a melee attack. Now we could make a separate melee attack that is like different if we want. But let's just do this for now. So like a more powerful attack that is like faster or something, I don't know. Because this melee attack, it's like telegraphing a little bit. I don't know if I want to have that. Like you could see the telegraph attack there. Now it's doing like a normal charge attack. Oh yeah, so the hunt is like when you're far away. Oh, it really went away. There we go. Now it's doing the hunt. Okay, it could be maybe a bit faster, maybe. And maybe the hunt should be longer. Let's do like 3 seconds, 200. Need to aggro first. Maybe the charge is too long. You know what? Let's do this. Let's add hunt attack melee trigger distance. So this is like we have melee attack distance is what? 50. Let's do like 75 and hunt attack melee fly speed. So it's like the idea is that once it gets close enough, it's gonna do some like a lunge attack. So it's gonna lunge towards you. So let's do lunge. Actually, yeah, let's just make a lunge attack fly speed. So this will be like 300. And then I guess we have like lunge attack damage is 1. Lunge attack duration 1.5 maybe. Attack hurt delay is gonna be like, I mean, I think it's gonna be like instant, so 0. Because it's gonna like, yeah, keep its sword out immediately and then do a lunge, like a, you know, fencing lunge attack. I don't know what it's called, you know, technically, but I just, in my mind, it's called a lunge attack right now. So then when we have hunt attack, so instead of going to melee, we do should lunge attack. Okay, so let's copy should melee attack, should lunge attack, can attack it. So basically we don't really care about the timer, I guess. Let's keep it in there, why not? It's always gonna be true here anyway. Yeah, so this would be lunge attack. Wait. Yeah, it's that one. Then we set the state to lunge attack. Now we need the lunge attack. So basically we can copy this. Let's make it, sure, that's fine. We're gonna see the difference anyway. Launch duration. Now velocity 0 doesn't really make sense. I'm gonna remove that, but we do want to get the monster to set the direction towards the player. It's monster, you just get direction to player. There we go. And yeah, we still need to create the attack. So I'm gonna keep the same attack information there. Update, we still have this, yes. We go back to aggro. Now, what we also want to do is we want to make the monster move in the lunge fashion. So I think the fly speed is always going to be the same. So this would be default fly. This would be launch attack fly speed and monster fly direction. So yeah, since the attack is basically following the monster, so we just need to move towards the player basically. And yeah, I think that's it actually. Now when it's hunting the player, is gonna do a lunge attack instead. And we might also incorporate lunge attack as a, you know, if you're in range of the lunge attack. Alright, come on, let's do the thing. There we go. Oh. Yeah. Okay, cool. But this was wrong. So this should be launch attack damage, launch attack duration. That could be the same. And launch attack hurt delay. come on, do the thing. Maybe we should not have knockback when it's... Oh, it did a launch attack. Ah. Okay, now I feel like I wanna like just try and fight this guy a little bit. Alright, it's doing charge. Yeah, I really like the evasion thing is working because it's like super fast. Oop, my controller is lagging here. Why is it lagging so much? It's like connected through Bluetooth, so sometimes it loses like connection. Okay, now it's fine. Oh. Yeah, the melee attack is still like, it feels like it's very weak because it's not really, it basically never connects, but whatever. Maybe the weapon should be even longer. I don't know. It feels like it's pretty long right now anyway, but yeah. Okay, well this is probably the most complex monster that I've done so far. Yeah, I'm pretty happy with that. Alright. Cool. Now let's see. Well, okay. I'll try it a little bit more. I also have this like mist ability. Well, actually I can't use the mist ability when it's doing a launch attack because it's like too fast. I can use it for that. But there's a little bit of cooldown with the mist ability, or it's a little bit delay. So if you use it right away, it takes like half a second or something. Okay, now it's never doing the hunt attack. Whoops. There we go. Oh, and of course, well, yeah. So that's cool. It seems to be kind of like balanced around that anyway. All right. What now? I mean, I can continue making some other monsters, I guess. I would like some monster to be like something that comes out of the ceiling, maybe. Or maybe something that spawns these guys. Like a huge flying carrier type enemy that spawns little ones, maybe. I don't know. Maybe that's too annoying. Because I'm trying to think also like thematically what these monsters is. I'm pretty sure what this is gonna be. That this is the one that we're doing, that we did right now. It's basically gonna be like a ghost with armor and weapons that's just flying around and yeah, attacking anything. Maybe it should even attack like other monsters. Like it could aggro other monster because it's kind of like a restless ghost that flies around. So while it does attack other monsters, maybe it's like, but it's also kind of hard to kill, I guess. What if we just added one more actually? Oops. Also, since they're ghosts, well, I guess if they have armor on, it does make sense if they can. Let's try. Let's. Okay, so now both of aggro me. Oh. Yeah, the lunch. Oh man. The launch attack is pretty difficult if they are like very close and they initiate the launch attack pretty fast. Oh, there we go. Pathing problems. That is an issue. Oh man. Yeah, I like it. Yeah, the pathing issue. Can't think of a really good way of solving that right now. We don't really have. I mean, one thing that we could add is like what I saw one time in one YouTube video, whatever, was if you add a field of path, you add like a field of basically like arrows pointing towards how to get to one point, basically the player in this case. And then, but if you're here, you can't just point straight towards the player because there's something in the way, so you have to path your way around. So basically each frame you could build up this basically vector field that points towards the like the closest way towards the player. Now it's gonna be tricky though, because how small would, I guess it depends on how small the arrows are. Like if you have, because these entities, like their collision box is different. This guy is like, you know, a rectangle like this. The grid is gonna be square. This guy will fit perfectly in the square, and this guy is like smaller, so this would also work. But for these guys, they're like taller than the tile, so it's like if the center point, if we go by center point, it's over here. We have an arrow that's like pointing straight down, let's say, so it's moving down. But once it goes over here, it enters this tile, which may be pointing straight left in this case, so straight down there. So now it's like gonna be going slightly down. But if we were, let's say we were up here, it's gonna point straight to the left. So first it goes down there, and once the center point reaches this tile, it's gonna try and go over here, which doesn't work, so it's still stuck. So I don't really know how to solve that problem. And we can't, yeah. Unless... I mean, maybe we can convert the monster into the nearest multiple of the tile size. So it would maybe be like, I don't know, it would be like this. And then maybe we can do something with that. Or maybe something like this, probably. But then the center is there. How would that work? Would we have to like count? No, I don't know, man. There might be something there though. Okay, maybe we can check for collisions, like which tiles is the monster in, and then take the vectors of those tiles this points over here probably, this points over here, and then we have one that points down. So how would that work? I don't know. Okay, I'm gonna refill my coffee here, BRB. We're gonna have to sleep on this, I think. But I think that could be a way to go. I mean, we could also do, maybe what we could do is have the ground collision, like we have like small monsters that always, we could have like multiple, I guess we could have multiple vector fields maybe. I mean, if you took all the three here and summed them up, I get at least the angle. Like it's only the angle we're interested in. So we have an angle there. They're gonna cancel out, or not cancel out, but they're just gonna be the same angle. And then we have an angle down. That's gonna like, it's gonna be like south or west by southwest, or however you want to call it. So it's gonna move like here. So it's still gonna find its way there, I think. And if it's here, it's gonna be like west. But the further down it goes, the more west it's gonna be trying to go. Yeah, it's not an easy problem for me, at least right now. But yeah, okay. I think that might be a way to do it. Yeah, I would have to maybe read up a little bit on that, because there has to be a lot of articles and stuff for around that. It would be cool if they could collide into each other there. Okay, this is kind of cheesing it here. Although if it does a lunge attack, you're pretty screwed. Okay, well, what to do now? I think I might, maybe we'll rename this, because I kind of know what it's gonna be called. And this is gonna be called something like, I mean, like Ancient Ghost or something, I don't know. Let's just call it that, it's fine. And I don't have a way to rename the files, unfortunately. Maybe I should add that feature in the editor. Yeah, I mean, it wouldn't be that hard, I don't think. Now this is gonna be called Ancient Ghost. Apparently it doesn't work. This one, ghost. Scene. Oops. Well, I need to add, you know, graphics and stuff for it as well. I think that might be the first monster in a long time that I'm gonna add some graphics for. Okay, and we're gonna move you to Ancient Ghost. There we go. Let's see if it still works. And I think I'll add a rename feature in. Oh, it didn't work. Okay, cool. Why isn't it working? Whoops. Test. Flying Monster 2 does not exist. I saved it. Well, this still says test flying monster for some reason. Let's see, let's restart. Now this says Ancient Ghost. Wait. Oh, I renamed the wrong one. Okay, that does make sense. There we go. Now it works. Okay. Okay. Right. So let's add a way to rename this, because I don't have a way to rename the actual file name here. All right. So now I have to remember this whole project. So this code should be in the asset manager layout. And we should have like, well, this is gonna be like an entirely new thing. Somewhere we have, oh, this is directory, node menu. We're going through all the files. Yeah, menu is kind of weird name maybe for this. This is basically the icon, the node that you see in the asset library. There's the text at the end. So basically here what you could do is add a drop down menu, like a context menu. What's this like? Debug message. Okay, well, whatever. You could add like a context menu. Here's the selectable. So basically here I want to add a drop down menu. And I'm trying to think where we have one. I think we have one in like the project layout. Here's like the main menu bar. No, it's not the main, it's the tabs. It's like the document tab list. Where is that? Oh yeah, we have like close others, close all. Here we go. Here we go. Here's a context menu that we can look at and use. And here's how you do it. So basically, begin context menu item. Which is all this here, document tabs, right? So here's a tab item. Okay, I guess this is the only thing you need here. And then in the menu you would have stuff. So let's add it here, I guess. And we will need node context menu. And we have like the node context. Yeah. Now we need to make this node context menu. All right. Actually, this could probably return a bool if you want to like invalidate the current frame. So I'm gonna say if this is true, we return true. Because of invalidation reasons there. Like if you rename the file, then there might be some weird stuff happening. I don't know. Let's just return false as a default. Okay, we need a way to rename the file as well now. So But we'll add a button here, and if we go and look, where was that thing? Here, so let's just copy one of those buttons, add it here. So here we should have, well, it could be delete as well, but I'm not gonna add it right now. But what we want is, we want rename. And that should open up some sort of UI. So where do we have that? I think we could just add a flag into the context. So let's go to the context, which is pretty massive. It's like, this has basically everything the editor needs for everything. And here we can add, basically, here we could add like rename asset, we could use the reusable text buffer for the input. We can use rename asset input target. We don't have a, oh yeah, we do have a document input, but we don't have an asset input. Well, rename asset ID, I guess. So whenever the rename asset ID is populated, we will show the, this is kind of convoluted maybe, but we will show the menu, or I guess arcane is a good way to put it. We will show the menu instead of having like is rename asset dialog open. We will just populate this with the ID and check this if we should show the dialog or not. Let's actually look at where this is used so we can copy this behavior here. Yeah, so here we have like the delete asset dialog. Let's also then add rename asset dialog. So we will look at asset rename ID. We will get the ID here. And yeah, we already have like the target, so this doesn't make sense. Rename node is, I mean, sure, whatever. Because nodes can be directories as well. Nodes can be directories. It can also be like non-asset. It basically all the files in the project directory and directories. It's a file node or directory slash files. Warning. Do you really want to delete? Enter new name for this node. This will rename the actual file slash directory. Also, it's interested me. What is the correct term? It's like because directory is very usual, but then you can sometimes you see folder as well. I wonder if like directory is like the more correct term, because that's what's used in like code a lot. So we do want to show the name. Maybe we just do this. Oops. Oh, these are unused. Okay, target. Oh yeah, so we do have the ID. Okay, wait. We might not actually have an ID. That's a problem. Let's do node instead. Let's do. Well, actually, this makes sense here. Let's make this node target. Well. Rename node target. Okay, there we go. Rename node target. We get the node instead. There we go. And rename node. I mean, using node to the end user also is kind of bad. It should really be like file or directory depending on the type. So it's like this is also the problem. I don't think you can do this. If you have like one. No, actually, what we could do is we could context and couldn't we do like alloc print? Do you need a sentinel? Yes. And here we can say rename s. But now I think the problem here is like if we say we cannot do this, so we say if node or we can switch on the node. Wait, file and directory. No, yeah, because this is a union enum, so we can switch on the node itself. Except it's a pointer, so we have to dereference it. And then we get file or directory. So if it's a file, we want file. If it's a directory, we want directory. I don't think you can do this. I'm not sure though. Although we probably want to have this in here. Get path, like get kind label something. Actually, this could be like this. I mean, we could do. That. So that's static now. That's like a static, like this. Right. And then here we can say instead of this, we do node get kind label, and then here this is gonna be window title. And then the sentinel needs a sentinel in the end, which is gonna be 0. Okay, so that's the title there. And if you say rename file or rename directory, I think it's probably, actually let's call this target. There we go. Okay, enter the new name. Yeah, we also need the input here. So we have a reusable text buffer. Now we'll just set this to, wait, no, we can't do that here. What do we want to do? Let's go. Do we have like input text? I forget. Reusable text buffer. So we're just doing this. Wait, where are we? Yeah. Oh. Pretty sure we can use this. Right. And then when we actually do the thing, rename, we want that new name is that. Now, a little bit of weird thing here. Like if you provide a name that has like slashes in it, that's gonna be weird. So maybe we'll just strip out that. I think if you try to put slashes, maybe we always try to strip out all the like reusable is equal to where would that be? Memory trim? No, not trim. Filter? No. What would that be called? I'm pretty sure there should be something here. I mean, it's got trim, so replace is not correct. Not split. What? Wait, is there no... Well, I guess trim kind of makes sense. Maybe no, maybe not. Collapse. Is there really no like remove? There's like everything and anything, but not remove. Unless I missed it. Which is like, it should be fine, because anytime you remove things from a slice, you don't need, as long as you don't need more memory, you should be fine. I mean, there's replace, but that's not really what we want. Sort, no, sort. Why? Trim is also nice, but I think it's only doing from, you know, the ends. Which is almost what we want, but we want the whole thing. Split kind of does that, but it like turns it into an iterator, so that's not what we want either. Okay, I'm just gonna Google real quick and see if there's Zig. You know, usually when you Google stuff on Zig, you don't get much help, but otherwise I have to write my own function here. Zig remove remove chars. Object. No, not replace. Oh, okay. As usual, there's no help to the game. Okay, let's just make a function then for that. I mean, I could just make the thing here, but I have like utils. Maybe here, I guess. Remove characters. We don't really need, it's gonna be like a mutation. Yeah, so that's this, so this, here's the source. And then we also need the characters. Which could be comp time, it doesn't really matter. Okay, so basically we go through each. I guess we could. Like each time we remove a character, we need to move the entire like string to the right, one left, like one place over, and we have to do that for every character that's encountered. So a very naive approach would be to just go through this, every character in the source, and then check if we get this character here, we don't care about the results. If we find this character in the source, then we will strip that out. Actually, you know what? We could just make an iterator. maybe. But that would mess up the iterator, I think. Split. Scalar. It's not a sequence. I don't think. I basically want all the characters in the delimiter. The delimiter should just be one character, but then you can specify multiple delimiters. Basically, is what I want. Separated by the byte sequence in delimiter. So this is not what I want. Split any. Returns iterates that separated by any item in delimiter. So yeah, so that's what I want. Split any. U8. We have the buffer here, source, and delimiter is chars. Now I just basically want to concatenate all of these things that we get from this iterator back into source. Let's put that away for a second. But yeah, so we do have access to index. We could modify the index, which is very good, because now we can say, okay, while we have an item here, this is the next part. We basically want to say how would this work now? So basically we want to keep track of the index here, and we want to say source I until source, so we're gonna copy from I to, so this index, how could this be null? I want to set this to no. That should already be correct. I think like the first one here up until the index that, so this index should be the, let's see what this is. So we start at the index, then the end, we calculate the end. Return that. So end might be before the index, I think here. Index is like the start of the, so yeah, so we have the length of the part. So it's gonna, so start is gonna be part length plus current index. That's the part that we want to like chop off, basically. Okay. I think what we want to do is we want to have an index that is like insert index, which is a nullable, and we start with null because at the start we don't need to insert the index. And so at the end we will set this to be the current. Wait. This would be like the current index plus part length. And then this is gonna be increased by part length, I think. Yeah, we'll see if we even need I here. But here's like, if we have an index that we need to insert into, then the start will be that. And the end will be this plus part of length. And then this will be part j minus start. I think. Yeah, so we're going through each part, and since this the split iterator, always the cursor that it has basically is always like gonna be further along than where we write to the string. We should just be able to loop through this as normal and then write back to the source as we go along. And then at the end, we will write, we will say index, but now it's, I think it's like null at the end maybe. Yeah. Buffer. So the last one, it sets index to null. We get the length of the last, yeah, we get the last part. But after that, we don't know how long it is. So I think what we need to do is we need to keep track of the length as well. So here we're saying length plus equals, well, I guess we have the I. Yeah, that's the same thing. Let's rename this to length. So length is 0. So we chop it off at the end, basically. Okay, I wish I could write tests for this. I mean, I guess I can. I do have tests. Test. What is this? Remove characters. I think that's how you do it. Okay. Okay, let's start with some string here. So input is gonna be this, delimiters slash, oops, and let's have like expected. It's gonna be ABC 1 to 3 txt. Right. Oh, but this needs to be mutable. Yeah. Why is it doing double indentation here? Oh, because of that. Okay. And then we do like lib, utils, no, layout, remove characters, delimiters, input, and then whoops, expect input, expected, and input. All right, now let's no, not npm. Zig build test, I believe. It's never mutated. Wait, this needs to be like an array, I think. This needs, yeah, this needs to be like this. Wait, how did you? Do this again? How did you make this here? I'm just reading a little bit there. Array of structs. Define string as array. Okay, maybe I just need to put some number here. Sure, why not? No, it's never mutated. Oh yeah, I need to put it like this. Okay, cool. Now we have some other issues here. Right, let's not worry about this for now. New name is unused. There we go. Still some issues. Expected 64, found 15. Okay, sure. I thought that like since it's like 0 sentinel, maybe it like could. Or do I have to do this? Let's do 64 undefined buff print input or Actually, no, this would be like, this is like the buffer. And then we have the input like this. There we go. Now what's the issue? Expected this found. Let's just catch unreachable. Or I guess we can try in. Can you do tries in tests? I mean, I guess you should be able to. Oh yeah, this is try. Oh. Well, let's just get rid of that. Expected this, found this. Okay, there we go. Now we can test this properly here. EX, interesting. Okay, so it kind of works, but there's like an issue at the end. So maybe this should be -1. But then its length is like 0. No, it doesn't make sense that it would be like -1. Man, it almost works. Why is there extra T at the end there? Yeah, because if you do like -1, well, I guess if we do like this, it would not wrap around. It still doesn't work. Wait, now we get TXXT. What? I thought the length would TTXT. This doesn't make sense. What the hell? Do I need to 0 the rest? That doesn't make sense. Okay, now it's complaining like A, B, C, D, E, F, 1, 2, 3. The difference, expected this, found 0. Isn't that what you want? Now I'm confused. It's a 0 sentineled byte string. So setting the end to 0 should be correct. End of string. Is it the test that's wrong? Like this expected this. Let's do this then. Let's do like const. Is the type needs to be the same? I mean, to me, this is the same thing. This should be like, this should add a 0 here at the end. Okay, well. No. Will that work? Oh, this var. What the hell? I don't. Okay, I don't understand. Is this a bug in Zig or am I? What am I? What's happening? End of string 0. To me, that's the same thing. There are 0 sentinel strings. Like, what if we did this? What if we didn't call this? We changed this to this. Will you still complain? Okay, now you don't complain. But what if we say input length is 0? What? Oh, wait. I understand. Yeah, okay. Okay, I think I know what the issue is. So basically, we need to have a result, which is the result here. Because, yeah, okay. So we need to get a slice that has lower length. Even though when you're working with like 0 terminated strings, they should count as equal if they have like a 0 at the end. Okay, I guess. Okay, well, so this should return this or this or yeah, let's just return this, and then we return source like this. Okay. And now I think this should be fine. No? Expected. This found that. Well, I know this is for a fact correct, so I would just do a pointer cast. There we go. Okay, cool. But now let's go back to say that expected is equal to A, B, C, D, E, F, 1, 2, 3, D, X, T. I will remove you and we'll try this again. And now it works. Okay, cool. All right. I wish I could do like var input equals abcdf 123 txt, and it would be a modifiable string, but this is actually not modifiable because you have to define it in terms of an array, I guess. What if we just do this? Yeah, it's that. Does this work? But now it's just an array. No, that does not work. Yeah, so you can't populate it like this is the issue, I guess. Okay. Okay, there it goes. So now at least we know that the function works, because it's always like when you do some weird logic like that, it's really nice to be able to write an easy test for it. And see that it, okay, yeah, it works. So now we can go back here and where are we? So I think useful text thing. Yeah, here we are. Okay, so now basically what we want to do is we want to say well, we can't really we can't really reassign this. So what we were gonna do is we're gonna ignore the result, and we're gonna say utils remove characters. I guess we want to remove both slashes in both directions. We want to remove dots, and probably anything else that's kind of a weird character, but let's start there. And then the source is going to be reusable text buffer. I mean, you're going to get some sort of weird OS error if you're trying to rename something that doesn't work, I guess. This should be a pointer. All right. Cool. So yeah, let's see what's going on here now. So we should get the new name there, and then now all we need is a rename like action. I'm also gonna do this so we get an ID for this input here. Okay, now we need like a rename action. Just like we have delete node, we should have a rename node. So this one does a whole bunch of stuff. I think we want to have a similar thing actually. So let's do this and that and rename node. Now we can go back and call this, and we just need to implement it now. So this is rename instead of delete. Yeah, so we have directory. I'm probably gonna finish this up, fix it so it works, do the actual rename to test it and stuff, and then I'm gonna call it here today. Okay, so rename. It's nice to get this feature in because this feels like one of those basic features that should exist. So rename node. So if it's a directory, well, we don't want to delete it. We want to rename it. rename. The old path is this, and then the new path is gonna be new path, I guess, new name, node. We also need new name here, which we don't need to be mutable. Oops. There we go. Okay, so in case of a directory, we simply rename the directory. However, this is gonna be quite a lot of changes potentially to the index. I think what we're gonna do is we're basically just gonna rebuild the entire index once we do this. Because right now we don't really have a good way of like dynamically modifying the index. So I think after we're done a rename, I'm just gonna rebuild the index. We don't really need to do anything with the nodes, I don't think, because the nodes, like a directory, the nodes inside a directory is not loaded. The only nodes that are loaded is the ones that are in the current directory, so you don't need to do anything there, I don't think. But the asset library or the index, the asset index needs to be changed, so it needs to be renamed. So this one would be that, and then we have maybe some error here, which we will catch, and we say could not rename directory to new name, and we show the error, and we return false, and then we should say or we have the project asset index rebuild index. So this one should, well, it calls rebuild index, which deinitializes, yeah. And basically, if this happens, we should probably abort. So we should return true at this point. We don't need to close the editor though, so let's remove that. We don't remove the node. Okay, so basically if it falls through, then we should invalidate, so that's fine. Actually, we should always rebuild the index. Okay. And for our file, we just rename. No, so this works for both files or directory. So let's just do that. Node path. Yeah. And the path is basically just getting the path, right? All right. That should be like relative to its. Yeah, it's relative to its own parent, so it's basically just a file name or directory name, I think. Hey, welcome back, Blue. Whoops. All right. New path, new name. Name, new name. There we go. All right. Do you want to look at the collision system a little bit? I'm just gonna make this work here, or test this out. So now we should have a rename thing. You should be able to rename stuff now, I think. We just need to put this somewhere. And we also need to populate this, which we don't do, so rename, right. So basically here is like context, rename, target equals node. There we go. No, I didn't. I waited until you were responsive or came back here. Let's see. So now we should do error union. Oh. Could not actually. Do you have thing? No. So there's no like context rebuild index now. Could not rebuild index. And if we can't rebuild it, that's kind of bad, actually. Well, whatever. Yeah, no problem. I'm just gonna test this out. I just implemented being able to rename files here. So I'm just gonna try this out here. So we have test flying monster 2, which is actually an ancient ghost. So I will rename. Interesting styling there. And this is gonna be called, so let's try cancel. Yes, it works. Okay. And this is gonna be called, oh shit, it has like entities there. Oh, this doesn't work. I am disappointed. Okay, well, is it relative to the root then? That's not good. It should just be the base name. Okay, let's do this. New names. Let's get the base, or not base name, dir name. Path dir name of this. Okay. And then new path should be, oh man, that was the problem with the paths. Well, let's just do this. Join alligator paths. So their name and new name. That should be the new path. Okay. Let's use this there. Old path. Let's just do this. Old path. Old path. Oops. Old path. Alright. Oh, that can be null. So if it's null, let's just do this, I guess. Or maybe dot. Oh, let's just do that. I guess if this is 0, then it's just gonna be a new name. So let's just guard ourselves there a little bit. Not make some weird join stuff happening there. And this should also be catch reachable. Okay. So great. Now also we want to, let's get this. And here we actually want to say their name. No, not their name. Actually, we want the base name now. Yes. Now we can just do target, get that. Is this also nullable? No. There we go. Okay. I'm disappointed that this doesn't work. But maybe it's because they use like their internal buffer and we can't modify it. Well, I guess we could, I think, but not through this buffer here. I thought it would use this as an underlying buffer, but okay, whatever. Let's rename now. So now we see this name here. Now let's just say ancient ghost entity type. Okay, so we also don't want the extension. We don't want to be able to change the extension, basically. The extension should stay the same. But I will rename this, see if it works. No, it crashes. Okay, great. Unreachable code. Interesting. Layout 160. So we did rebuild the index. Let's load this here. It might actually have been renamed. I don't know where it went though. Forget where this project is. All right, I'm gonna look in here, and we're gonna look for the thing. Ancient goes. Oh, it. Okay, so it removed the dot. Okay, so yeah. Wait, oh. Now it's just called ancient. Ancient ghost entity type JSON. There we go. Those JSONs. It's the actual sort of I guess project data. Let's see. So in the entity type, you have things like what properties could the entity have. Like if you have a door, it connects to some other scene or some other point, stuff like that. Like in the scene, but the entity type describes what properties an entity could have. Okay, let's start and see now. So this should now be ancient ghost. There we go. Oh yeah, the open tabs. This should also like rename this. No wait. Yeah, I think it does. Okay, so I just want to fix a couple of issues here. So we actually don't want the extension. I think if we get the base name and then we just get the name, it's gonna be like slice 2. Oops. Slice 2 dot. Okay, let's try this now. All right. Thanks. Good luck. Okay, let's see. So now it says ancient ghost. So we should. But we still need to fix the actual rename action here. Yes, so we'll go in here, the old path, we get the dir name, we need the extension, it's gonna be extension of the old path, and this will be, actually now, let's remove this, because now we need like the extension as well. Alright, let's see if this works. Okay, ancient ghost, we'll rename you to ancient fake ghost. Dun dun dun. File not found, okay. Oh, that was a weird way of doing it. Oh, it thinks that this is a okay, so this shouldn't be like joined like this. This should be like concatenated. Okay, new name with extension. This should be like concat. Wait. Oh, also it took like the wrong one. It's not the full extent. Okay. Let's do. What would this be? Index of, like, we just want the first dot. And there you can't have dots in your directory names, but who has that? I guess this would be like the base name. If we take the base name of the old path, look for the first dot in that, and then slice from that position to the end. We get the name with the extension here, and we join it with the dir name. Man. Is memory corruption possible in Zig? If yes, how can we perform address sanitization? Memory corruption. I mean, memory corruption. I mean, basically in Zig, you can make a pointer just like in C, and basically have it point to anything. I mean, you can convert it. You can convert a pointer to an integer if you want, and then back again. So you can just make a pointer point to anything basically. But the operating system, like you're operating in virtual memory, but so basically I think the only memory that you could corrupt is your own process memory. But I'm pretty sure. But yeah, it is possible, and that's also the whole thing about you have to be very careful when you're dealing with pointers and invalidating them and stuff like that. Address sanitization, like what do you mean by address sanitization? Like memory address, or like do you mean how we know if a memory address is correct? Because that's just, you know, how would you say it? It's just you have to know when you can use a pointer and when you cannot use a pointer. Like at some point, if you free a pointer, for example, then you know that after that point, that pointer is now invalidated. So it could be taken over by some other allocation, and now you have to worry about that. Well, you don't have to worry about that, because if you account for that, then you're fine. If you debug, how you debug it? Well, when you have like some memory issue like that, you usually get like, if you're, let's say you're trying to write to memory that you don't own, so basically you're trying to write outside of allocated memory, then usually you will get like a segmentation fault error. And in Zig, actually you don't get a lot of information about what happened, so you have to actually try and look for places where this could happen, and it's actually quite hard to do, because you have to, there's no hint like, yeah, at this line this happened. So you basically start to put some logs out, or you can debug with the debugger to go through line by line if you want. But it's very hard to find those kinds of issues because it doesn't tell you like which line it happened. It just says segmentation fault, and I think sometimes you can get maybe like a core dump or something to see like in the assembly where it happened, if you have like, and then you probably could get like the line of code where it happened because of debug information. But usually when you get a seg fault here, you just get like, it just says like, yeah, there's a seg fault at this address. But usually it means that you haven't properly initialized the pointer, or you're using an invalidated pointer. So if you're working and you've tested your program and it works at one point, and then you add some stuff, and now all of a sudden you get seg faults, then, you know, one huge clue there is like, look at the code you just changed or added, or yeah, usually you have some sort of idea of where you need to look. And then you also build, you know, a better understanding and intuition of what you can do and what you can't do, and what is a good pattern, and in order to avoid those kind of problems. Let's see. So okay, well, what's happening here? Okay, expected type. Found this. Index of. All right, let's do scalar. Now, what is position? What does this mean? Start index. Oops. Yeah, we need a scalar. If we don't find the dot, I'm gonna say 0. Actually, this doesn't make sense. This is like the base. This is like, okay. This won't work because we're looking at the base name of old path and not old path itself. So I think what we need to do is we need to do like index of scalar position, and now we can do, we have to look at old path, but the start index is going to be their name.length. So now we're looking at the correct thing, because we're indexing in old path, so we should be using old path as an actual source, and then because otherwise the index won't line up. Or we could just add their name, I guess, as well. But this should work. And then we get a nullable. So if it doesn't find anything, we start from 0. Actually, actually no, we should actually. So let's do like extension start. If so, this could be null. So it's like extension is like if extension start is, if we have that, then this would be extension is like this. Otherwise, it's gonna be an empty string. There we go. All right, hopefully I'll get this working soon here. And this is concat catch original. Okay. So let's just go through this again. We have the old path, which is relative to the root directory of the project, not the operating system. And we have the dir name is here. We have the extension start is the index of the first dot, right? Because the built-in extension function took the last dot, not the first one. So we want the first dot to be that is not in the dir name. So we're basically skipping ahead there. And then the extension is going to be, if we found an extension start, it's going to be from that point to the end. So that should include the dot, I'm pretty sure. And then, well, if we didn't find an extension, then the extension is empty. And then the new name with extension is just concatenating new name with extension. That should include a dot as well. And the new path is just their name joined with new name extension. Yes. All right. Now let's see if this works and doesn't crash. Alright, let's go to entities. I'll just rename it to there. Okay, well. Okay, I think it did rename it. But this is not changed. Oh, I think maybe the index. Oh, we should basically reload the. Well, it does work, so that's good. Oh shit, we got like a million things happening at the end here. Memory address leaked. Hang on. Yeah, okay. Well, wait. Format. Oh, right. It's so yeah. Okay. We have a bunch of stuff that could be that should be freed here. So let's just do that. Oops. Allocator free. New name with extension. I think I have a string allocator maybe. Maybe I don't. Maybe I'm just lying. But let's just free these. Because you could have, what I have like in the other project is every frame. I have an arena allocator that you can allocate things that should just live in that frame, and once the next frame starts, it frees up everything in that frame arena. So basically you don't have to free it yourself, you can just add things to that arena willy-nilly and it will free everything automatically. So which is useful for things like temporary strings, so you don't have to like free everything. The downside though is that like if you're mixing patterns like this, you constantly have to check, okay, which pattern am I using here? Should I free this here? Do I not free this here? What do I do with this? You know, I think the best way maybe was to create a new struct or something that handles it or something. I don't know. Yeah, there's probably something in C like that as well. I'm not that well versed in C, so you have to excuse my ignorance there. But okay, well these are the things there. But then we also have the somewhere here, somewhere base name. Here we go. Alec print. Yeah, so this one should also be freed. There we go. I think that's it. Let's just try this again and see if we caught them all. And then I'm gonna fix the issue with the node thing. Okay, that works. If we go back and forth, this should still say that still says that. So that also works like doing that. Oh. Okay. So now I think we're back to where we were before. So I don't care about these leaks. There's only like 2 leaks that's happening when you exit the program. So that's not fine, or that's fine. I mean, now the thing that we're missing, I think, is like when we rename, we should, well, we're rebuilding the index. We should also go to, we should also like set this path. Yeah, we should just be able to set the path here. Like this path is the node is stored in a stable place, so we should just be able to set the where, yeah, or get like I guess we can get the pointer, or this is the pointer, I think. No, but we need to set the pointer. New path. Oops, it doesn't need to be a pointer, it's already a pointer there. And basically we switch on, now this needs to be mutable. We switch on self, but then we get this mutable version, and then we set this to new path. But we also need to deallocate the old path, so we also need an allocator. To free the old path. Oops. There we go. So we set the path to new path. Alright. And now you actually need to be a pointer. And we don't need to dereference there. Alright. Okay. So it wants you to be a sentinel. Is there a join Z? Yes. Okay. So we defer every time after we declare an allocator. Yeah, so after defers are happening like at the end of the scope where you define them. So it's like, it's nice because then every time you allocate something, you can have the deallocation code on the line after, but it won't execute until the scope is done, or yeah, it will happen at the end of the scope. So it's a nice way of kind of making sure that you see that, oh, here's an allocation, but it doesn't have a deallocation associated with it. So if you have a pattern where you always put it at the next line, you can more easily catch those mistakes. No, it still didn't change here. Ooh. Okay. Man, there might be some other place. Wait, is this invalidated? Oh, so now we actually don't want to invalidate this or free this. We need to actually set that, yeah. I mean, another way would be to duplicate in here, so we duplicate it. That's probably better. Yeah, let's just duplicate this. Dupe said. Because this that is zero terminated, yes. So we're duplicating it, and then we can free it here. There we go. I mean, it's kind of like having a explicit destructor, if you want to put it like that, maybe. And then for things that lives longer than the scope, you have you usually have like a deinitialize function. That is the convention there. Okay, well, this is kind of weird. So I think I know what the problem is, but you can see if I hover over, you see the tooltip that shows it says ASDF now, so that works. This says ASDF, but this label didn't change. So next problem here. Now where would that be? I mean, we have a path. Oh, we also have a name. Okay. So I guess we need to change the name as well. I mean, the name should always be like... Yeah, it's always like the base name. So we should just... Yeah, we should just... Like when you set the path, you should set the name to be the base name. Oops. Of path. But then we also do that. We should probably call this function instead of doing the other thing. We also want to rename there. Now this is kind of stupid because name is always going to be the base name of path. So we could make it into a function or just make it into a slice that you know, points to the same location. Oh no, that's not good. Oh, I see. Oh, slice. Okay, we are also doing like a slice too here. Okay, there we go. Is that what garbage collectors do? Free memory of the scope answer is it? No, well, I mean, even in C++, you have, it's not garbage collection, but what's happening is that if you have a class, I mean, usually if you have a class, usually you say new. Well, new makes a new pointer, so new actually allocates. It's calling some standard allocation stuff for that. So that makes like a new instance. And then you say delete. That will destroy, that will free up that class instance. But it's also calling the destructor automatically when you do that. It's calling the constructor when you create a new. And it's calling the destructor when you delete it or when you free it up. But it also does it if you just create it, like if you don't use well, can you actually do that now? I forget, but I think it's also doing it if you create like if you just have it on the stack. You don't use new. I don't know if you can do that. I don't remember. But basically, when you go out of scope, it should also call the destructor if the lifetime is only in the scope. And then I think, but that was like, you know, my long time ago knowledge of C++. Nowadays you have like different kinds of pointers and stuff. I don't know. It has changed a lot, but. Like smart pointers and stuff like that. which I think is kind of determining the sort of the lifetime of the pointer. Okay, there we go. Now it works. Great. I want to rename you to Ancient Ghost. Great. And do you also reflect this? Yes. So if I change you to ASDF. Oh yeah, but this name is different. So this is not the same as the file name. So that does make sense. But if I go in here and I change the file name to ASDF, save that, go back here. Now it says ASDF here. But I don't want this to be called ASDF. There we go. Now it's Ancient Ghost. Okay, cool. So we did that. Okay, now let's go through. I'll get more leaks. No. Do I care about this now? Okay, I won't go through this now. It's just leaks. Whatever. Yeah, let's go through the collision detection a little bit. So I promised you this, and then we'll call it here. So the collision system. So basically, I wonder if I should make a. I should probably open up GIMP or something. I don't know if I should. Like if I show code, it's gonna be maybe not that clear on what's happening. Let me open up GIMP here so I can show what's happening. 1 second here. Takes a while to load. Let me refill my coffee in the meantime. All right. Let's see. Open GIMP. Are you there? Yes. Okay, let's make a page black. Should be good. Okay. I do have a drawing board, but it's not connected right now. Well, whatever. Okay, so basically, I'm using something called a quad tree. I usually don't do this, so bear with me here. Quad tree. Now, what is a quad tree? Well, basically, let's say you have a bunch of entities. Let's make these like blue or something. So you have a. Hang on. I need to change the color mode. There we go. Okay, so we have like a bunch of entities here. Oops. Let's also. No, that's fine. Okay. So we have a bunch of entities. Now, how do we know if they collide? Well, there's a very simple formula for two rectangles. And let's make a red rectangle here. I don't know how, much in depth I should go here, but let's say we have a, so we'll mark these. This is like the top left. And we have bottom left, bottom right, and top right. And then we have the same for the blue one, but I'll spare you that. So basically, what you want to do is you want to check each point. See if I remember. No, it's not these points. No. Well, it kind of could. It could be those points. But basically, we have the X and Y position here, right? And then we also have like width and height. This is how I, look at it. So then we can define something here. So we can define the top. The top is like which point in the Y axis is the top for the rectangle, and that is gonna be, that's just Y, right? And then we have the bottom. What is the bottom? Oops. Bottom is gonna be Y plus height. So a very simple equation here. Y plus this length. Now we're at the bottom. Y is up here. X doesn't matter at this point. We're only concerned about the Y here. So Y is up here and bottom is down there. Or down at this line here. Okay, and now we need the left. Left is just X, so this is basically the same thing. And right is X plus width. Okay, so we got top, bottom, left and right. And we have got the same thing for blue. I'm not gonna write that out. So in order to know if we've collided, we need to check the left part, this side, is this like to the left of the right side here? So is this one on the left side of the other's right side? So it has to be there. The left has to be on this side, and then the right has to be to the right of the left side. It's a lot of right and lefts here, so it's a little bit confusing maybe, but basically then that means that if this is to the left of this and this is to the right of this, that means that one of them has to be in this region here, which means the x-axis now is colliding, right? And then you just repeat the same logic for the y-axis. So the top needs to be below, or wait, the top needs to be above the other's bottom, and our bottom needs to be below the other's top. Yeah. So then if both of those conditions are true, then we know that we are then we know that we have a collision, like a rectangle collision. So to make this, so usually I call these just T, B, L, and R. And then if I have two rectangles, I will have like T1, L1, B1, R1. And then if I have, and then we have like T2 and so on. And so in order to calculate this, there's a very simple formula. So this is basically just, so let's start with T. So top one should be, let's see, it should be less than or equal. I guess you can also have equal, it doesn't really matter that much, but it depends on what you want basically. But if this is less than the bottom two, then that part is now correct. And then we have and, let's just make How do you make this? Wait. No, wait, that's not correct. It's like this. Yeah. Okay. And let's make this, whoops, sorry, white. And then the bottom, oh my god, sorry. The bottom, no. The bottom of one. So this bottom should be below the other's top. So it should be more than, if you're, now we're working with computer, this is computer coordinates, so y is flipped, so you have to keep that in mind as well. Okay, so this should be more than top one, or top two, I mean, yeah. And then we basically, yeah, we do the same thing as we have and here as well. Actually, the and should be white. Doesn't matter that much, but whatever. So then we have and now we say left one should be less than right 2, and right, whoops, come on, right 1 should be more than left 2. And if all these conditions are correct, then we know that we have a collision. Okay, that is the sort of the basic foundation here of rectangle collision. But this is not a, like, this works, and you can go and check for every monster against each other, or every entity. You might have some ground here as well. Like, let's say you have some ground here. Now you can just check against this rectangle to see if you're colliding with the ground as well. But that's not really the end of the collision story, because this is, if you're gonna have an efficient system, you don't want to check. It's gonna be like a lot of checks. This is what, if you do a so-called brute force algorithm, which means that you're basically checking every entity against every other entity. That is gonna be so brute force is equal to O of n squared algorithm, and that is very, very slow. Especially like so it increases the computer resources that you have to have, or that you consume, is gonna be exponentially, I think it's called, well, it's gonna double every time you add more. Wait, not double. Well, it's gonna increase a lot every time you add more entities. So if you have 10 entities, that's gonna be 100 checks. If you have 100 entities, that's gonna be 10,000 checks. So it's increasing a lot every time you add more. Yeah, so it's like it doesn't really hold up there. So that's not what I'm doing here. Hello, Rupert. How's it going? Yes, I'm still going. However, I will just go through this and then I'll hang up. Events. So, do you mean in the collision here? So I'm gonna explain how I do it. Now I went through. I have implemented like 3 different algorithms, but I'm only using one. So basically, you see quad tree here. We haven't got into the quad tree yet. But the quad tree is going to help us to more efficiently find which rectangles are colliding. N factorial. I'm pretty sure it's n squared. It's like if you start with this guy is gonna be 1. This guy has to collide with this, and this. Okay, well, there is a... Okay, it's not entirely true. It depends on which brute force algorithm you're using. I'm talking about the most naive brute force algorithm is n squared. But then there's also, as you say, n factorial. I believe it's like you skip the ones that you already checked, basically. So if you check, you start with this one checks against all others, so that's like 4. Then you check with this one, but then you don't need to check this one again. So you skip that one, and then you only check the rest, so that's like 3. And then this one you check only 2, this one you have to check 1. So that's correct. Well, that's more like, that's not really factorial, I don't think. That's like 5 or 4 plus 3 plus 2 plus 1. So it's like the addition variant of factorial. I don't really know. Is that like a geometric series or something? I don't know. But it's less than n squared. But yeah, and that's a very easy fix to actually increase the efficiency a lot. So I'll just put this here. I'm not sure how to actually, like 1 plus 2 plus ... n, like that. Okay. So it's not really n factorial, because that's gonna be a lot. That's gonna be really huge. But it's this one, yeah. Anyway, that's correct. You pointed out to a correct thing there. But the quad tree improves this with... Quad tree is actually, I think it's like O. It's close to being like O log of n. It might be like n of n. I don't remember. But what it's doing is basically, it's first... so how I do it, first I sort of have this boundary. So I'll make a boundary like this. Okay. So everything that's inside this boundary is now part of the quad tree, let's say. And so how this works is that we basically build up a tree of rectangles, or in this case, well, it is rectangles, probably, unless it's squares, but whatever. And so what's happening is that first we divide everything in 4. So there. And then we check, like, okay, which entities are in which quadrant. So, for example, this one is in this quadrant. And then we have these two are in this quadrant, and this one is in this quadrant. And let's say this one is in this quadrant, just for simple sake here. Now, if you, for example, want to check this guy, if this collides with anything, now what you do is you check first which quadrants are you colliding with. So you're checking, like, are you colliding with this quadrant? No. Well, then we skip that. Do you collide with this quadrant? No. We skip that one. So we don't actually check against these two entities. We check only against this quadrant. And then we check against this quadrant. And are we colliding? No. So we're not colliding at all. Except we are colliding with this quadrant, but there's no other entities here, so there's no collision. So that is how you can easily, divide the problem up and improve performance a lot. But we're not done yet. So imagine you have more entities here. Like, we have a bunch of entities over here, basically. Okay, well then, you have some sort of function that will say, okay, well, we need to split this up even more. Okay. But now these quadrants are actually like they are belong to this quadrant. So if you check now, this guy is gonna check against this quadrant. No. This quadrant. No. This quadrant. No. Okay, well that was not surprising. So let's check again with this one. So are you colliding with this quadrant? No. This quadrant? No. This quadrant? No. But this quadrant we are colliding with. Okay. So then we're gonna check all of the children of this quadrant. So we're checking this quadrant. No. This quadrant, no. This quadrant, no. Then we skip all these three. And yeah, so that's kind of how it works. Wait a minute, that's how they do terrain collisions with loads and stuff. Well, in 3D, there is a version of this in 3D, which I don't remember what it's called, but it's basically the same thing except it's with cubes instead of like squares or rectangles. So it's basically like yeah, it's just one extra dimension of space, but it's the same idea. But there you divide in 4. Wait, how many cubes fit in one cube? It should be, no, it's 8. So I don't know if it's called like octo trees or something like that, but it's like instead of dividing by 4 squares or 4 rectangles, you divide by 8 cubes or cuboids. That's yeah, works basically the same. And then this equation is just that you add another dimension and you add like 2 more checks or something to get that dimension. Yeah, the tree part is basically just, this is the root of the tree, this is the whole thing. The root of the tree contains 4 children, which is these 4 quadrants. So these are kind of like branches. And then each of those branches contain even smaller branches and so on. They produce oxygen and are a very convenient data structure as well. So yeah, I don't remember what my algorithm was like, when it stops, but I mean, it should stop when there's no more entities that fit in the quadrant for one. If there's only like one entity that fits, it doesn't make sense to keep going, I guess. But I don't remember exactly. But I can actually show you. Because if I open the game and I hide GIMP, I can press a button. Not that one, this one. And here is the actual quad tree in real time. And here you can see the green line is the boundary. So that's the like the main, the green line that's like in on the edges. That is the entire, that's the root of the tree. And then you can see the blue lines are that's the like the level 2 or whatever you call it. If the root is level 1, the blue lines are level 2. And then the red ones are level 3. And you can see that where my character is going is like populating the tree. And the yellow one is yeah. So basically it's probably a little bit inefficient now, because the blue one should really, like, if there's only one entity in this blue here, it doesn't make sense to do it like this. We should really get rid of this, because this is like one more check, the red one here. And even if I go into the yellow part, that's also like one more. But then you have to keep in mind that it might not actually be more efficient, because the algorithm, since it's so tightly, it's happening each frame. Each frame is building the entire quad tree. So it's going through all entities each frame and building the quad tree. But that's still faster than, you know, brute force collision detection. Yeah, so this red one is a child of this blue one. And the blue one is a child of the green one. So the green one is the root parent, or the Adam and Eve primal ancestor. And the blue one is like generation 2. The red one are generation 3. But this red one is only a child of this blue square or rectangle here. Well, dynamic. It's interesting that you say dynamic, because it's actually not dynamic. It's actually rebuilt from scratch every frame, the whole tree. When you say dynamic, I interpret that like I was trying to make a dynamic tree, which basically means that you keep the whole structure in memory throughout each frame. You never you don't discard it and rebuild it. You keep the same structure, but then you update the positions of entities within the tree, which would sometimes make new squares or whatever. But I tried doing something like that, but it was very, it was kind of hard to do. So instead I just rebuild it every frame and make that as fast as possible. But that's it works. And but the collision system is definitely the bottleneck, especially when you have like a lot of I can show you also. It's kind of hard to see. These are all the entities currently, and you can see the ground here. It's kind of hard to see because there's white lines here, and that outlines each entity. Now for the tile map, I actually merge these tiles into one entity. So this is one entity here, this ground thing, and also the entire base here. But over here we have a bunch of entities. Like all of these could be merged into one entity, but I opted to not do that because it was getting more complicated, and it works good enough right now. I mean, it looks like they're moving, but they actually aren't moving. It's like we're rebuilding the entire world every frame. So it's like, it's just showing what the state is right now. So it's actually not like it just happens so fast that it looks like it's maybe like dynamic, but it's not. Red share is the red square is sharing 2 quadrants. So actually not. There's no red square sharing 2 quadrants, because this square is only a part of here. It's just that you don't see, like this only belongs to this blue, and this one only belongs to this blue. But if there's an entity here, then it will show this square, and it kind of looks like they're the same, but they're not. It's actually two different rectangles. Like here. Now it's okay. Now it moved out, but now this is actually a wall here, a red. So this is one, and this is one. You never have a node in the tree will never have more than one parent. It will always have one parent, except for the root, which doesn't have a parent. But all the nodes have exactly 0 or 1 parent. And that is also why you can go down the tree and skip the rest. So you can go down this blue one. This character is only colliding with this blue one, so we only need to consider anything in here, which right now there's nothing in here, so the checks stop. All right. Okay. Well, that's gonna do it. We made some progress, I think. Yeah, I really like the ancient ghost enemy. I just need to make some graphics. I'm gonna try and do that until next time, and then we'll implement some animations. I'll try and also use a animation library that oh man, okay, animation library that, or plugin to GIMP, that I'm gonna use, and we'll see how that goes. But that's gonna be it for this time, so thank you very much for joining and chatting with me, and have a nice day, and I'll see you later. Bye bye.